So our relationship with BNSF goes much further back than my time here at Bartlett and West. Certainly am aware of projects that started in 1990, and our relationship with them has evolved over time. But for the purpose of this presentation, we're talking about the facilities work that we do. So my team provides predominantly MEP and structural services and architectural services for their maintenance facilities all across their network and system. So we get around a lot. We travel to a lot of their different sites and facilities all across the Midwest, but these are rail maintenance facilities. So outside of their corporate offices that we help them with too, we get into some really interesting projects. It's probably some of my favorite work that we do for them. We work in a lot of old facilities. I would consider a new facility for them to be 1980s on average. And then most of what we work on are, 1880 to 1910s. I mean, these are 100-plus-year-old buildings. So there's a lot of components that go into that. Obviously, we evaluate these facilities from time to time for them to make sure that they understand what is needed to keep the building itself functional. And then there's all the components within the building that support the processes and maintenance services that are performed in there.
So Havre is north central Montana. I can't remember how many miles it is from Canada, but you're getting close. And it's a main spot up on what they call their High Line. They have a shop built, I want to say 1944, 1945. And they have a drop table. Traction motors are what drive the locomotives. They have a wheel with a motor attached to the side, usually 6 per train unit. And they can, as you can see in the picture, this is a storage area where they have used ones. The wheels wear down differently. They can get irregular wear patterns on them. The motors can fail. There's some other things that can go wrong with them. So they basically have to change them like you change tires on a car or truck. Inside Havre, they have 2 tracks where they can drop the traction motors. When we arrived there, only one of the surfaces worked. The other one was defunct for some reason. The work surface can drop out and you can drop a single axle. The table can also, the whole thing can drop out and you can also drop all 3. That's the drop table. That's the existing system that was there. Everything was well worn. The old lift mechanism was threaded units. The newer one they wanted was hydraulic, so easier to repair, easier to replace. Components like valves and hoses. The old wear mechanisms the old threaded mechanism would just wear out. And so instead of having 4 threaded bolts essentially on each corner, lifting that table up and down, now you got 4 cylinders. There's some tables in the middle that can do finer adjustment, and overall it can lift 120 tons to compensate to handle those locomotives and their weights.
This project is down in Lincoln, Nebraska. They got a couple of yards in Lincoln. One of them focuses predominantly on locomotive service and repair. And then this yard is actually focused on freight cars. So freight cars also have to have a lot of maintenance done to them. They have regularly scheduled FRA inspections, but they have wheels on them, wheels and axles, just like locomotives do. The only thing they're lacking is the traction motor piece. So this project is one of those really cool. It's one of my favorite projects that we've done for BNSF. It's actually the second one we've done. We did an exact model of this type of wheel lathe in Topeka, I believe 2018, 2019 timeframe. And then we just finished this one up in Lincoln this last year. The need here, this is a high production facility. They do over 1 million wheel sets a year. They've got 2 older wheel lathe models currently functioning in the shop, and they wanted to increase their production. So we had some existing machinery, surface mounted machinery. We picked this spot, we got rid of that stuff and decided that this was the best place to put a machine that they ordered. Now, this is a very expensive machine. The machine itself is over a $2 million purchase. It is manufactured in Germany. It takes over a year to build it, test it. They have mock pits in their facility. They put it all together and make sure it works, and then they break it all down into a bunch of little pieces and put it in crates and ship it across the ocean. And hopefully, by the time it gets there, our hole in the ground is ready for them to set this machine on. And since we've done this before and we were highly successful with it, and this is a very technical project, they called us back on this one, said, you guys got to get involved. We got to make sure that this thing's ready to go when it gets here, because when I spend this kind of money on a machine, I expect it to start working the second it hits the ground. So this is just what it looks like in the shop before we got started. Now this machine, you can see some of the wheel sets in the background there that it picks up and it lathes them down. It resurfaces the wheel. So again, these things, the axles themselves weigh about 800 to 900 pounds a piece, depending on the type that it is. And then the wheels themselves also vary in weight, but roughly about 500 pounds a piece. So you're over 2,000 pounds per wheel set. So this machine picks it up, profiles it, it scans it with a laser, does all of its fancy calculations, and it starts lathing it down. And bang, we started digging a hole with a very large excavator inside of a building. So you're driving through an overhead garage door and you're putting plating down over existing tracks to make sure you're not damaging anything, and then you're going to town with a rock hammer, essentially. And here we got some of the formwork that has been pulled off on some of the initial pours. So this is where you can start to see some of the magic happening and coming together. Now here's a picture of the actual machine after it's been set. Now it hasn't been fully commissioned yet. The rail isn't in there, but you can see it's a pretty good sized machine, and they look pretty sharp when they're brand new. They got a lot of smarts and gadgets on them. You roll it into it, it captures the wheel set, it locks onto it with these wheel chucks on the side. It's got one on each side. These heads on this wheel lathe, they're about 50,000 pounds a piece. On their own. So they're well equipped to pick up that 23 to 2,500 pound wheel set and spin it around and do whatever they need to do to them to get them back in get them profiled back to the right specification. We certainly are appreciative of having that flexibility to do all of that in-house for them. That's another trait of ours that they really enjoy having access to, and they know that they can call us, and there's really not a whole lot that we have to reach outside of our borders for to service their projects. So we pretty much keep it all in house. We do it well. We understand how they like to operate and what their needs are, and it's just a really great partnership all around, and it couldn't happen without great team members. Blessed with that, and appreciate being able to work with them every day.